there we go. Okay, so today, review, huh? Tomorrow is a quiz. 12, 4, 17. All right. So, number one, find the first 5 terms from the following formulas. Okay, so that's pretty easy. It really is. So we know that the first term is 3, right? So it says to make the second term, and what you could do is make n, because n's always just 1, 2, 3, dot, 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 right? So the first term is 3. The second term, n of 2, would be the first term minus 7. So we just take 3 minus 7, we get negative 4. Then we take the next term, remember, we take the next term, subtract 7, we get negative 11. And then we subtract 7 from that, we get negative 18. We subtract 7 from that, we get negative 25. Again, if you get confused with this, let me show you on the board. So, watch, if you get a little confused, here, if you let n be 2, right, so the second term would say, take the first term minus 7, so that was the first term. If you want the third term, right, remember how we did this? If you want the third term, you take the second term minus 7, and it just keeps following that pattern, right? That confuses you? Okay, now, let's take a look at number 2. Same thing, okay? First term is negative 5. To make the next term, we're just going to multiply that by 2. To make the next term, take the previous term, so I get a negative 10. To make the next term, I take the previous term and multiply it by 2, and I get negative 20. To make the next term, I take the
first term, and then
right. So, sure. So one way to do it is you plug in to get the second term, make n be 2. So then you take, that'd be the first
so
term.
A n is 2.
So
is A in the second term?
A n, okay. Shh, guys, I need it quiet. Okay. So here's how it works. Okay. If n are these numbers, okay, we already have the first term. We already have a1, right? So to make a2, in fact, I'll do it on the board so you can see it. Okay. I'll do it on the recording because you might want to watch this tonight. Okay. So if you use the formula, if I need to find a2, then I made n be 2, right? So then I'm using the formula, let n be 2. It'll be 2 times a to the, let n be 2. Okay. So if I need the second term, n is 2, right? If I simplify this, it says like a2 is equal to 2 times, well, that's a1, right?
How do you know what the second term is?
Let me do my very best to explain this one more time. Okay, you gotta watch. I will do. Okay, well, I'll try my best. Okay, I know the first term, right? So I want to make the second term. So to make the second term, I want a2. So that means in my little formula, I change that to a 2, which means I need to make n be 2 to make the second term, right? So a2 would equal 2 times, well, if I put 2 right here, 2 minus 1 is 1. So I'm going to look at the first term, which is negative 5. I'm going to multiply that by 2, and I get a negative 10. Now let's make the third term, okay? I don't normally do it this way, but this is how it works, okay? Let's make the third term. So if I want a3, okay, if I want a3, I'd go, okay, 2, now remember, n is 3 this time, right? N is 3, so I'll put a 3 right here. I'll go 2 times a to the 3 minus 1, okay? Which a3 then is 2 times a2. We know the second term is a2 is negative 10, right? So we go 2 times negative 10 and we get negative 20. That's the third term, right? Okay. So then let's say we want to make the fourth term, okay? So I want to make a4 because that'd be my fourth term. So a4. So we're going to let n be 4, right? So we'll go 2 times, remember n is 4. 4 minus 1, right? Which is, that's a3, right? Isn't that a3? Well, a3 is the third term, which is negative 20. So we go 2 times negative 20, we get a negative 40, okay? So now tell me what's going on what's going on? We're just multiplying by 2 each time, right? So we can make the fifth term just by saying, hey, wait a minute, I see the pattern. Multiply by 2, multiply by 2, multiply by 2, multiply by 2, and I get negative 80, okay? And that's how these recursive formulas work, okay? So, something that might help you on the recursive formula, okay? This, a to the n minus 1, we always call that the previous term, or the term we just wrote down, or the term we just wrote. Okay, this is the previous term. So then to make the next term, we take the previous term and multiply that times 2. Okay? All right, let me keep going because I know this is difficult for you. Okay? Now, for 3 and 4, it's in explicit form, which is so much easier. It's in explicit form. It's recursive form that's the difficult one. Okay? So again, let's find A1. So A1 would be made by 6 times 1 minus 10, right? So that's negative 4. So A1 is negative 4, okay? Yeah.
Oh, never mind. I got it.
Okay. So let's make A2. Okay, let's make A2. So make A2. All right, we're going to do the same thing. Plug in 2, right? So we're going to make, so we go A2. Cameron, I think there's a review sheet somewhere right here. Okay, right here. So to make A2, we're going to go, okay, I'm going to go 6 times 2 minus 10, right? Which is a 12 minus 10, which is a 2, right? Okay. So then I want to make the third term, right? So if I want to make the third term A3, I plug in 3. 6 times 3 minus 10, which is 18 minus 10, which is 8, okay? Do you see a pattern yet?
Yeah.
Going up by what?
4.
6, right? Going up by 6, right? It's all good. So you see a pattern, right? So add 6, what's the next term? 14, and then 20, okay? All right, that's how it works. All right? I'm going to need a calculator for the next one because I'm going to need to use it. But first of all, A1. A1. Guys, you need to stop talking. Okay. Boys. Okay, to make A1, plug in 1. I'm going to use 0.2 times 3 to the 1 power. And I'm going to use my calculator, okay? So I can go, okay, I can do that. So clear, I'm just going to go, can you guys see that? Barely. No, okay, so I'm going to go 0.2 times 3 to the power of 1, right? And I get an answer of 0.6, okay? So A1 is 0.6, okay? A2. To make A2, just plug in 2. So to make A2, we'll do it all over again. We'll go A2 is equal to 0.2 times 3 to the 2 power, right? And just use your calculator, okay? So I'm going to go, all right. I'm going to go, if you can see it out of the glare. There we go. So I'm going to go 0.2 times 3 to the power of 2, and I get an answer of 1.8. Yeah, 1.8. 1.8, okay? So if I need to make the third term, I'll go, let's see, 0.2 times 3 to the third power, and I get 5.4, right? If I need to make the fourth term, I'll let this be 4, right? Let that be 4. Use my calculator. Yeah. Times by 3, and I get 16.2. Make the fifth term, I'll just make that a 5.
So recursive is doing this repetitively, but the explicit can just go straight through it, isn't it?
Yeah. See, the explicit gives you the form that works, right? The recursive makes you make one after the other, right? The fifth term, we'll do the same thing, times 3, and we get...
What's going to be in the test tomorrow?
Uh-huh.
Just this?
Just what's on here, 48.6. Okay, there it is. So, let me go back what Nikolai said. So, the recursive, you just have to do what it says. Keep subtract 7, subtract 7, subtract 7, subtract 7, okay? Multiply by 2, multiply by 2, multiply by 2, multiply by 2, okay? The explicit form is you have to plug in 1, plug in 2, plug in 3, plug in 4, or plug in 1, plug in 2, plug in 3, plug in 4. I just use your calculator, okay? Does that make sense? Okay, yeah. Okay, now, number 5. We pull out a little bit of graph paper. It says graph them. So this should be really easy, but do not connect the points. Don't connect the points. So, okay, right off the bat, I get a ruler. That'll work. Okay, and I'm going to go up to 9. Okay. All right, to graph this, I'm going to make sure Okay, I get my first term. 1, 2, 3, 4, 5. There's only 5 of them. And then I'm going all the way up to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm just going to graph them. So it's just going to be dots. That's all it's going to be. I'm going to have a dot then, or a value at 1. I'll have a value at 3, a value at 5, a value at 7, and a value at 9. Okay, so it's first term, its value is 1. Second term, the value is 3. The third term, the value is 5. Fourth term, the value is 7, and the fifth term, the value is 9. That's it. Do not connect the dots. If you make a line to connect the dots, I will mark it wrong. Okay? Do not, because there isn't a half a term. It's your first term, second term, third term. So there's no terms in between, correct? Don't connect them. Keep them just dots. Is that a function? Yeah, it is. Okay, what type is it? Arithmetic, isn't it? This one's arithmetic because it's straight. It's linear, right? All right, let's take a look at the next one. So I'm going to go 80, 40, 20, 10, 5. So I'm going to have to, change my axes quite a bit. Yeah, so I'll probably have to go by maybe 10s or something like that. Probably go by 10s. So I'm going to go first term, right? Second term, third, fourth, fifth. I'll go 10, 20, 30, 40, 50, 60, 70, 80, right? And I'm going to put a value. The first term will be at 80, so I'll put a value there. Second term is 40, I'll put it there. And then 20, 10, and then at 5. This one's geometric because we're multiplying by 1/2 each time. So this one's geometric. Okay. How am I doing so far? Easy, right? Everybody should be able to get those 2 graphs without a problem. Yeah, Cole?
What was the name of the first graph again?
Arithmetic. Yeah, right there. It's arithmetic. So if it's a straight line or if it's linear, then we're adding 2 to each time, right? We're adding 2, adding 2, adding 2. Okay. All right, now, what type of sequences are they? Hey, what do you know? There they are. This one is arithmetic, right? Arithmetic because you're adding the same to it each time. And this one's geometric because you're multiplying by 1/2. So this one's geometric. Okay. Are they functions? Yes. Yes, they're functions.
What makes them functions?
Great. Every x value has only one y value. Yeah, I will. So every x value has exactly only one y value, right? The first term you can't have 2 first terms. You can't have 2 first terms. You got a first term and a second term, but you can't have 2 first terms, can you? You got a term, and then the second term, and the third term, but the second term can't have 2 parts, so it doesn't make any sense, right? So every x value has only one, let's just say 1, my bad, 1 y value, okay? Okay, number 7, find the 40th term. So there's 2 ways to do this, okay? You can get your calculator out and just keep adding 2, adding 2, adding 2, adding 2, adding 2. You can, that will work. You can make this, just add 2 until you get 40 terms. Or we could use a formula. Now first of all, this is arithmetic. Because what we're doing is we're adding 2 each time. So we'll say D is 2, okay? Yeah. Okay, it's arithmetic. So I have a formula, and the formula's up on the board. Arithmetic, see it says AN.
Wait, D equals 2?
D is 2, yeah, because the difference between each term is 2. So we have a formula, it's over there by the Christmas tree. A of n equals A1 plus n minus 1 times d. That's the formula we want to use, and it actually turns out to be a pretty easy problem if we use the formula correctly, okay? So we want the 40th term, right? So we're going to say, okay, let's make a 40, right? So we want the 40th term. A1 is the first term, which is 3, plus n is 40, because we're looking for the 40th term, so I'm going to go 40 minus 1. And the difference is 2, because we're adding 2, so the difference is 2. So all I have to do is just use my calculator to get my answer. Easy. Is it easy? I'm just going to go, what is 3 plus, oh, turn it on. I'm going to go 3 plus 40 minus 1 times 2, and it's 81. So if you were to make it, keep making it, keep making it, keep adding 2, adding 2, adding 2. By the time you get the 40th term, you get 81. This is faster. So we know that A40 is 81. Much faster to use the formula. Now, if you can't use the formula, just keep adding 2, adding 2, adding 2. It'll take you a while, but you can get there, okay? Okay, number 8. Find the 11th term. 1, 3...
81 or 81?
81. Yeah, 81. Okay. All right. So find the 11th term. Now, this one's geometric, and we have a form for the geometric also, okay? If you look at the geometric one, it's kind of hiding behind the tree, but it's the A of n equals A1.
How do you know if it's geometric?
Great. Take a look. What's going on? Can you tell me what's going on?
It's multiplying by 3.
There you go. Multiply. The term multiply tells you it's geometric, okay? Yeah. Totally right. So, now we want the 11th term, right? So let's go A11 equals, the first term is 1. The multiplier, that's the R, is 3, because we're multiplying by 3, to the 11 minus 1 power. And again, I'm just going to let my calculator do the work. Okay, let's go let the calculator do the work. Clear, we're going to go, all right, 1 times 3 to the power of 10. You okay with 10? I mean, there we go. Let me show it. Okay, I mean, I don't need to go 11 minus 1. I know 10 is 11 minus 1, right? Did we get that? Boom. I get 59,000. 59,049. Okay, and that will be the 11th term.
1 times...
Yeah, it's big, isn't it?
1 times 3?
Mm-hmm.
1 times 3 equals 59,049.
But to the 10th power.
Oh, it's...
To the 10th power, right? So here it is in the calculator. See to the 10th power?
We did the 10th power is that.
Yeah, it's huge, isn't it? That's, remember we talked about those, remember we did the Skittles?
Oh.
And all of a sudden the graph just went boom like that, right? They get big fast, don't they? Yeah. Okay, number 9. So the inside equilateral triangle is 6. So this tiny little one here, let me show you. This tiny little one here has an area of 6, okay? That area has an area of 6. So then if I keep making this triangle, check it out. The next one would be like something like this, right? It's going to be super huge, right? It's going to be a bigger one there, right? And then you got another one that gets bigger and bigger and bigger and bigger, and we can't draw them because it's just too huge, right? So if I want the 10th one, first of all, how much bigger is each triangle? Okay, you got to be smart. Think about it. So the yellow triangle,
You fit 3 in each.
almost. How about 4? Because you have to include the one in the middle. Does that make sense?
4 times as big.
4 times as big. Good. So if it's times, is that arithmetic or geometric? It's geometric. And we have a formula for geometric. Okay. Now it says recursive formula. So we're going to say A1 is equal to what?
R.
A1 is equal to
It's the same thing as
6.
above.
And then we're going to go AN equals 4 times your A to the N minus 1. Okay, that's a recursive formula, right? Recursive formula says write down the first one.
I'm confused. Why aren't we doing the same equation as the one above?
Great. We want to use, because it says recursive. So there's 2 ways to write formulas. One is recursive. Right. So there's recursive and there's geometric. However, to find the 10th, I want to use the other formula, right? You agree with that? Or I just have to keep multiplying by 4, which you could. You could take this 6, multiply by 4, multiply that 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 by 4, by 4, by 4, by 4, and you can get your answer, right?
So there's 4 equations.
Or just keep multiplying by 4, or let's just use an equation. Now, the explicit forms are better. So if we go a of n equals a1 r to the n minus 1 power, this is the advantage to using the explicit formulas. It's faster. So I want the 10th triangle. So I'm going to go a10, then it's right here. a10 is going to equal the first term, which you know is 6. Our multiplier is 4 to the 10 minus 1 power, okay? When I get done, Nikolai, I'm going to answer this question for you, okay? Let's just go 6 times 4 to the power of 9. You guys okay with 9? The 9th power, right?
I hate the number 9.
Oh, yeah, there it is.
It's one of the worst numbers statistically in the world.
Is it?
9 for a whole
Yeah.
year.
So, how about 1,572,864 centimeters squared, okay? Now, Nikolai, hopefully I can explain this. So there are two ways, wait till you're done writing that so I can explain it to you, okay? There are two ways to do sequences. One is using the explicit formula, which is the way we like because it's the one that works the best, okay? The other is recursive. Recursive isn't good for much except for it kind of tells what's going on. It really says 4 times. That's what you're doing. It's multiplying by 4, okay? The one that helps us get something further away is the explicit formula, okay?
Yeah, but there's a different explicit formula for geometric than arithmetic.
Right, and that's why I've got everything up on the board for you. It's all up on the board for you, right? Okay. Okay, ready to turn the page? Well, that's why it's up there. So you don't have to memorize it, right? Okay, turn the page. Okay, number 10. Here we go. So a band arrives in Leavenworth and finds tickets. Sales. Pre-sales are great. Oh, I guess Landon could name his band now, couldn't he? But he's not here to name his band. There we go. They have already sold 200 tickets on the first day and average 24 tickets per day for 7 days. Okay, express the first 4 days of sales in subscript notation. Okay, so you ready? T1, which would be ticket 1. So day 1, we have 200, right? Does that make sense? T2 is going to be 224. Right? We got our 200. This is our first day. We show up and then all of a sudden we sell 24 tickets. T3 is going to be what? 248, yeah. T4 is going to be what? 272, right? So T5, we'll only need 4, right? So now, this one's actually pretty easy. Got to think about it. If A of n is 630, then what's A of n plus 1? 654. Yes. What'd you do? I just added 24. That's it. Because we don't know what it is, whether it's the 10th, 20th, 50th. We just know this is going to be the next one, right? But I don't know what that is. That could be the 100th day, but I know that's the next day. One more day, right? So you add in the 24. Good. Okay. Now, what are the sales on day 10? Yeah. So, 2 ways to do the sales on day 10. You can keep making this and keep making this and keep making this, right? Or we have a formula, right? Is it arithmetic or geometric? So we've got an arithmetic formula. So let's say we want to find A10, right? Which would be A1, which is my 200, plus my 10 minus 1 times my 24. So I use this formula right up above. I use that A of n equals A1 plus n minus 1 times d, right? I use that formula because it was arithmetic. And I'm just going to let my calculator do the work for me. So what'd you get? Did you already get it? 416. I'm going to believe Ben. He says 416. All right. Is that what you got too? Thanks, Ben. Okay. Now, this should say, instead of tick sales, you should say ticket sales. It's all good though. We're not really selling ticks. We're not really selling ticks. We're selling tickets. So, you know what? The cool part is we pretty much have this formula here. But if we need to make a formula, just make sure that n stays a variable, okay? If we need a formula, we're going to keep n as a variable. So I'm going to write a of n equals 200 plus n minus 1 times 24. And that's our formula. That's it. And we could use that formula for this ticket sales for any particular day, okay? Okay, 11. After Seattle, the band starts the tour. The week before they leave, the sales are at 1,800 for that week. Over the next 10 weeks, sales begin to fall by 15%. Oh, they're not a very good band, are they? Word gets out. They can't perform live. They're bad.
Whoa.
They might make good records or good CDs in the studio, but they're bad on tour, huh? So, list first 3 sales for the first 3 weeks. Okay, so T1 is 1,800, right? T2, well, how can we find out what the next one is?
I multiply that into 1,800. That'll get 15%.
Let's take 1,800, yeah, times, you ready? 0.85. Ooh.
Oh, because
Oh, yes. Oh, 0.85? Because we lost 15%, how much would be left over? We lost 15%, how much would be left over? We could do 15 and then we'd have to subtract. That's more work, right? We could multiply times 0.15, find out what they lost, and we have to subtract it from 18. That's just too much work, right?
to multiply it by 0.85.
So let's go 1,800
It's 15.
times 0.85 is 1,530. T3, how are we going to find T3?
Do it again.
Let's do it again. Let's multiply this number times 0.85, right? Does that make sense, 0.85?
Yeah.
Yeah.
You can't get a half.
Well, you can't get a half ticket, so we'll say 1,300, okay? Because you can't have a half ticket, right? And then how are we going to make, that's it, first three sales, okay? What will be the sales after the 10th week, okay? 2 ways to do it. Good, you guys are here. I'm recording, so you guys can watch it tonight, or just come on over, right? We're decorating the tree tonight, though, but come on over, right?
Oh, we are?
Yeah.
Wait, get on my spot. Like, hold on, how late?
I don't know.
Can we start at like 5?
Yeah.
Because I need to be at Annie's at 7 for practice.
Okay. All right. Okay, so
Annie, that's
2 ways. So we could, okay guys, listen, let's think about this. We could keep multiplying by 0.85, multiplying by 0.85. Right here is the review. Here, Julia. And then Nick, you're going to sit where you belong. You can sit over there. Okay. Hold on for a second. You want to give one to Landon?
let me give you one more, please.
For Isaac. All right.
Cole, it's your fault.
Cole can sit there, but I have to move.
You just don't worry about it. Right, make it easy. We'll put you next to Cam. We'll make it easy for today. Nick, we're still recording, so I'm waiting for you guys so I can finish this up, okay? All right, now. So, you ready? I'm going to finish this. I got 2 questions to go. Take a look at it. So, I'm multiplying by 0.85, 0.85, 0.85. Yes. So, what I could do is just keep doing this until I get to the 10th. Or let's just use a formula. Is it arithmetic or geometric?
Arithmetic.
It is. No, it's
Can I
geometric.
say something?
Yeah.
This is what
Huh?
wait, can you check this?
Let me do it. I don't know yet. Hold on.
Alright.
So let's do geometric because we're multiplying by 0.85 each time. So we have a formula. A of n, a1, r to the n minus 1 power. So what are we multiplying by each time? So we want to put 0.85 there. What's our first term? So let's go a of 10 equals 1,800